Hello everyone, my name is Gary Corlett. I'm a remote sensing scientist at EUMETSAT, working in the surface temperature radiometry group along with my colleagues Anne O'Carroll and Igor Tomazic. In this presentation, I'd like to talk to you about some future evolution of our Copernicus marine surface temperature products with specific relevance to coastal regions and high latitudes. On this slide, we give an overview of the collection for marine surface temperature products. So the main evolutions are to the SST product, where we will introduce updates to the Bayesian clear sky detection, especially relevant for coastal regions. We are also including a new SST depth product at an estimate of 20 centimeters to support the primary SST skin retrieved from SLSTR. And we'll also be including the full nadir swath. We have a new sea-IST surface temperature product, and this will be a combined product with SST at high latitudes. This will use a retrieval algorithm developed within a project led by DMI and Metno. We will also use a PPS cloud mask developed by the EUMETSAT NWC SAF, and this will be a separate product. All of the activities to develop the prototypes have been completed, and pre-operational products are now available on the Copernicus Wikeo DS, and they're available approximately within 6 hours timeliness from the 1st of April this year. Please see the web link provided for further details. Operational deployment within the EUMETSAT ground segment is expected to occur in spring 2025, but this is subject to confirmation. On this slide, we summarize the main improvements to the Bayesian clear sky identification. This was the outcome of a study led by the University of Reading. The main updates are in the daytime only, and these include a revised prior adjustment for optically active waters and the use of visible channels instead of thermal channels for textural test, where we now use the standard deviation in channel S3 instead of channel S8. This is, as a note, only an improvement in daytime. As well as the updated prior, a new preprocessor step has been included to give a better agreement and alignment between the visible and shortwave channels with the thermal channels. And the standard deviation for channel S3 is output as a direct product from the preprocessor. In addition, we have revised the land-sea masking using a distance to land estimate now, and also we have updated the radiator transfer model to RT12 12.3. The image on the right shows an example on the left-hand side of a visual imagery over the Bohai Sea, where on the right-hand side you can see the current operational cloud mask, where now most of the optically active waters are flagged as cloud. In the bottom on the left-hand side, you can now see the advantage of using SST3 instead of LSD8, and on the right-hand side, the improved cloud mask for this particular case study. For further details, please see the paper linked from Claire Bulgin from the University of Reading. On this slide are two more case studies showing improvements to the cloud mask for the collection for SST products. These were identified by the Copernicus Marine Environmental Monitoring Service. In the top example, here we have general overflagging along the coast in the collection 3 products on the left hand side. Particularly you can see along the southern coast of Italy and around Sicily. And on the right hand side, the overflagging is significantly reduced. Please note that there are small differences between the land-sea mask now in both cases, and this is one of the steps that does improve the data quality. On the bottom example, we have a traditional example of overflagging of frontal zones, and on the right hand side, these are now significantly reduced in the collection 4 output. The circled area is a very interesting area. As you can see, this is still flagged as cloud in the collection 4 product, and this is a very significant injection of cold water into the Gulf Stream, around about 10 degrees cooler than all of the water surrounding it, and this has not been picked up by the cloud mask as it is not properly represented in the prior, and most SST products on this particular day did not show this particular cold water injection. So along with our main sea surface temperature skin product, we are introducing now a sea surface temperature depth field. This is following the nomenclature introduced by the ESA SST CCI project, and here we now provide a depth SST at roughly 20 centimeters, and this is generated by calculating an adjustment using a combined skin effect and diurnal variability model and driven by operational fluxes from the ESMWF daily model. On the right hand side is an example of the Mediterranean Sea showing the SST skin at the top, and in the bottom is showing the skin minus SST20 differences. And here you can see in the reds some strong diurnal warming events, and these are mainly prevalent in the open ocean, and it is interesting to note though that in many of the coastal zones we do not see this significant warming, and this at the moment is due to the resolution of the prior data used as input, and this is something we will be looking further at. We will also now be providing uncertainties at both depths. So this will be in the form of a total uncertainty, as well as providing the components that have been used to derive that uncertainty estimate. At the moment, again, this is following the practice introduced by the ESA SST CCI project. So our collection for marine surface temperature products will now include sea ice surface temperature, and this is in a new product which will be available only for high latitudes, so above 50 degrees in both hemispheres, and it will either have an estimate of sea ice surface temperature, a marginal ice zone surface temperature, i.e. a mixture of both SST and IST, or an SST estimate. And the algorithms used were developed in a study led by DMI and METNO and are shown on the slide. Further details can be found in the provided link. The product itself is aiming for an accuracy of 3 Kelvin with a goal of 1 Kelvin, and these are based on the GCOS requirements. As well as the main temperatures, we are also including uncertainty estimates very similar to the SST product, which will also include the total uncertainty plus its components. The data images on the right hand side show examples on the left hand side for a nadir only product, and on the right hand side for the dual view product. At the top for SLSTR-A and SLSTR-B, and these are showing sea ice surface temperature only from our pre-operational data for April 2024. Cloud mask identification in the collection for sea ice surface temperature products will utilize the EUMETSAT NWC polar processing software cloud mask. This is available, and further details from the link shown on the slide. There are several possible outputs from the cloud masking software that we can use, including a main cloud mask, a quality flag, and now a cloud probability estimate, and a methodology that's been defined by Steiner Eastwood from METNO within our Cypher Mass project, and further details can be available on the report on the slide. We would like to propose some updates to the GRIST data specification as a result of our development of the Copernicus collection for marine surface temperature products. At the moment, the IST product is based on an existing product generated by the EUMETSAT OCSAF. However, we are only proposing to include one temperature field, which will be called surface temperature and will either be SST, IST or marginal ice zone temperature as discussed, and will be identified with an L2P flag type variable. We suggest that the GDS is now updated to include options for a combined product, and this is in the support of a suggestion that was already endorsed at last year's GRIST meeting. In addition, we would like to propose two optional fields are included in the GDS. The first one being total column water vapor to aid with validation. Secondly, the uncertainty and its components, if felt necessary, as optional fields. There are still some ongoing development activities, particularly to the Bayesian cloud mask and also the diurnal variability model we used to adjust SST skin to SST depth. For the IST product, we'll still have some optimization of the PPS cloud mask to do, and also some refinement of the surface classification and uncertainty model. One point we'd like to note is the calculation of SSES will be extremely difficult for sea ice surface temperature due to the lack of in situ data, and we will likely remove this from the final product. So in summary, pre-operational products for the collection for SLSTR marine surface temperature products are now available from Wikeo. These are roughly available within 6 hours of timeliness, and we expect operational deployment next year, but this date will need to be confirmed. The collection for products are two safe format products, one SST and one IST, and each file contains two NetCDF files, one for the dual view and one for nadir view. The collection for products offer significant improvements in coastal zones with the addition of the preprocessor and the coastal updates to the Bayesian clear sky mask, and we have a brand new high latitude product which is either SST, IST or marginal ice zone, and this utilizes a different cloud mask from the EUMETSAT NWC SAF. Finally, we propose some updates to the GDS for a new combined SST and sea ice surface temperature product, as well as optional fields including total column water vapor and uncertainties. Thank you very much. For further information, please see the details on the slide.